Hey guys, welcome to the Nickbit channel. Today I'll be going over question 18 in the AMC10b 2021 year. So the problem states, a fair six-sided die is repeatedly rolled until an odd number appears. What is the probability that every even number appears at least once before the first occurrence of an odd number? So first, if we draw a diagram, let this number right here be the first occurrence of an odd number. And here, let this be n numbers right here. Of these n numbers, we need to have each of the even values of a die appear at least once here. And so first we can find the probability of this happening. That of these first n numbers, each of these appear at least once. And then we multiply by 1/2 to account for the probability that the next number is an odd number. And so to find the amount of ways for the first n numbers to have 2, 4, and 6 at least once, we can do 3 to the power of n, because each of these n numbers has 3 choices, either 2, 4, and 6. But when we do 3 to the n, this overcounts, because of these n numbers, you can have all 2s, all 4s, all 6, or all 2 and 4s, and all 4 and 6s, all 2 and 6s, and so we overcount a lot of possibilities. So first, of these 3n, we subtract the possibility of all the n numbers being 2, all the n numbers being 4, and all the n numbers being 6. So let's subtract 3. Next, we want to subtract the possibility that all the n numbers contain exactly 2 numbers, 2, 4, 2, 6, or 4 and 6. And of these 3 even numbers, 2, 4, and 6, we choose 2 of them to appear in the n numbers. And when we choose 2 of them, for each of the n numbers, there's 2 to the n number of ways to assign each of the n numbers 2 and 4, for example. And then of these 2 to the n, we subtract 2, because of these, if we have 2 and 4 and have 2 and 4 of all these n numbers, there is a possibility that all of these n numbers are only 2s, all of these numbers are only 4s. So we have to subtract 2 to account for this. And so we can add this to this overall probability. So 3 choose 2 is 3. So it's just 3 times 2 to the n minus 2. And the overall probability for this is just 6 to the power of n, because for the first n numbers, there's 6 possible values, 1, 2, 3, 4, 5, and 6. So we have to put this over 6n, and the summation is just n is equal to 3, since n has to be greater than or equal to 3. The reason for this is because if n is less than 3, you can't have 2, 4, and 6 appear exactly once. So you need n equals 3 to infinity. And let's evaluate this small part right here. So this part right here is just 3 to the n minus 3 times 2 to the n plus 6, which is equal to 3 to the n minus 3 times 2 to the n plus 3. So what this ends up happening is n is equal to 3 infinity to infinity 3n minus 3 times 2 to the n plus 3 over 6 to the n. And we can split this into n is equal to 3 to infinity 3n over 6n minus summation to infinity 3 times 2 to n over 6 to the n plus the summation of n equals 3 to infinity of 3 over 6 to the n. The first expression is simply just 1/2 to the n, so it's 1/2 n equals 3 to the infinity. And to do this, we can just use infinite geometric sequences. So the infinite from n equals 3 to 1/2 n is just simply equal to the first term. The first term is 1/2 to the power of 3, so it's 1/8, minus 1 over 1 minus the common ratio of this geometric sequence would just be 1/2. And what this ends up becoming is simply just 1/4. Next, we want to evaluate this section right here. This section right here, n is equal to 3 to infinity, 3 times 2 to the n over 6 to the n. 3 times 2 to the n over 6 to the n is just equal to times 1/3 to the n. Because 2 divided by 6 is 1/3. So what this ends up becoming is the first term. The first term is going to be 1/9, because 1/3 cubed is just 1 over 27 times 3 is 1/9. And the common ratio is 1/3 once again, so minus 1/3, which is equal to 1/9 over 2/3, which is equal to 1/6. Next, we have infinity, n equals 3 to infinity, and we have 3 over 6 to the n. This is equal to, so 3 over 6 to the n, so 3 to the 6 to the cubed, over 1 minus 1/6. This is equal to 1 over 72 over 5 over 6, which is equal to 1 over 72 times 6 over 5, 1/12, which is equal to 1 over 60. So, evaluating, right here we get 1/4 minus 1/6 plus 1 over 60. This is equal to 15 over 60 plus minus 10 over 60. 10 over 60 plus 1 over 60, which equals 6, which is equal to 6 over 60, which is equal to 1/10. So the value of this is 1/10, and because the value of this is 1/10, we do 1/10, and since this value is 1/10, remember that we have to multiply it by 1/2 from here, because the last number has to be odd, and the probability that the last number is odd is 1/2. So your answer is going to be 1 over 20. So with this problem involved infinite geometric sequences, and basically just realizing that if you have anything that's going to infinity, you can write this as an infinite geometric sequences. Thanks for watching.